Welcome to the Deep Dive. We're the place you come to get straight to the heart of complex, specialized topics, fast. Our goal is simple: keep you informed, especially about the tech shaping critical industries. And today, we're diving into something pretty groundbreaking, a solution targeting a major challenge in manufacturing: how to train people for high-risk, specialized jobs. We're talking high-pressure die casting, or HPDC, and a really interesting virtual reality training program from HPDC Pathshilla.
That's a great place to start because, the stakes in HPDC, they're incredibly high. It's a precision process, yes, but also involves extreme temperatures, massive pressures.
Right.
And the industry constantly struggles with skill gaps. Training takes a long time, and practicing complex stuff is just prohibitively expensive, sometimes dangerous. So the goal of this VR program is pretty clear. Help engineers, managers, executives, doesn't matter if they're seasoned pros or new folks, give them the practical skills they need to really excel, boost their expertise, and frankly, make operations more stable.
Okay, let's unpack that right away. Because when you talk about training for something involving, pouring molten metal, why is VR the game changer? Is it just a fancy tech upgrade, or is there something more fundamental compared to, say, watching videos or even traditional apprenticeships?
It really boils down to safety, efficiency, and the economics of it. You touched on the key thing, immersion. HPDC is inherently risky.
Yeah.
If a trainee messes up during live practice, maybe they misjudge preheat, sequence the machine wrong, the cost can be huge.
Yeah.
We're talking wasted material, sure, but also machine downtime, maybe even a die failure costing six figures.
Wow.
VR uses advanced tech to create this safe but realistic space. You can practice setups, maintenance, those critical safety steps over and over with absolutely zero real-world risk. No cost, no stopping production.
So for our listener, maybe the professional trying to cut risk and speed up getting people skilled, the real win is that it's actually hands-on. It's not just absorbing information passively.
Exactly. You're building that muscle memory.
You're virtually physically doing the steps.
Precisely. You are in a virtual environment, learning by actually doing. And the content, it's designed very carefully to mirror what people face on the shop floor, down to the technical details.
Yeah.
That feedback loop, try something, see the result immediately, no real consequences. That's how you build confidence fast in tackling real production problems.
Yes.
And what's also interesting, the sources mention the hardware. They specifically call out using proper VR headsets, like Meta as the preferred one. That tells you they view this as a serious professional simulation tool, not just some gimmick.
That detail about the hardware does matter, signals seriousness. But let me push back a little here. Training in a clean, perfect virtual world.
Yeah.
How well does that really translate to the actual shop floor? The noise, the heat, the unexpected variables. Does the VR account for that kind of real-world chaos?
That's a fair question, and it comes down to the design of the training scenarios. Okay, the environment might look clean, but the problems you solve aren't simple. The focus is on mastering the process parameters, the troubleshooting logic, things that hold true regardless of background noise.
Okay.
By making you nail these complex sequences, like, say, lockout, tagout, or setting very specific injection parameters, the program standardizes the human part of the equation against that variability. If you master the correct logical steps in VR, those steps are still correct when things get loud and messy.
That makes a lot of sense, standardizing the human response. All right, let's shift from the tech itself to what's actually being taught. This is where it gets really interesting. You mentioned the curriculum covers, what, 4 main areas?
Yeah, 4 core pillars for successful die casting.
Let's start with the heart of it, the HPDC process module.
Right, the process module, that's the foundation. It covers the essential operational skills anyone working the machine needs. Things like loading and unloading dies the right way, setting them up correctly.
The basics.
The absolute basics, but critical. Running the machine, preheating components, even prepping things like cleaning and coating ladles.
Yeah.
Get these wrong, and you're setting yourself up for major quality issues down the line.
And it sounds like it moves pretty quickly beyond just the basics into some really technical settings.
Sure.
I see mentions of teaching the first phase, second phase, and third phase settings.
Yeah.
Now, for someone listening, maybe a manager not on the floor daily, can you quickly break down why controlling those 3 phases, the speed, the pressure, is so absolutely vital?
Oh, absolutely critical. These 3 phases define the metal injection cycle. So the first phase, that's the slow approach. The metal fills the shot sleeve and runners slowly to push air out ahead of it, minimize turbulence. basically avoid trapping gas. Get this wrong. Big defects later.
Okay.
Then the second phase, this is the power stroke. The plunger accelerates rapidly, filling the actual die cavity very quickly before the metal starts to freeze. The speed here really dictates the surface finish, the part density.
Right.
And finally, the third phase, sometimes called intensification. After the cavity's full, you apply and hold extreme pressure as the metal solidifies. This feeds material into the casting as it shrinks, preventing voids. So mastering the interplay, the speeds, the pressures, when to switch between these phases, well, if you don't get that right, you simply can't make a consistently good part.
That really underscores how specialized this is. And I also see this module covers degassing the metal. Why is that included?
Yes, degassing. Crucial for the integrity of the casting, it's about removing dissolved gases, mostly hydrogen, from the molten aluminum before you inject it. If that gas stays in, it ends up as porosity, tiny bubbles trapped inside the metal, which severely weakens the final part.
Makes it potentially unusable.
Exactly, especially for structural or high-stress applications. So the VR lets you practice the correct procedure for ensuring good metal quality, which is a fundamental but sometimes overlooked.
Okay, so that's running the process. Now, moving from operating the machine to preserving it. The second pillar, prevented maintenance. This sounds like it's all about protecting that investment and avoiding that massive downtime costs you mentioned.
It's entirely proactive, yeah. The whole focus is stopping failures before they happen. This module dives into maintaining the key systems, the lubrication system, vital for all those moving parts, the filtration system, keeping hydraulic fluid clean, the hydraulics themselves, which provide the injection force, and of course the electrical systems.
So it teaches how to spot trouble early.
Precisely. How to do efficient performance checks, recognize the subtle signs that something might be about to fail long before it leads to a complete breakdown.
And that ties directly into the next area, doesn't it?
Yeah.
Safety. Because doing maintenance means working on this powerful equipment.
Absolutely. It's a natural bridge to the third pillar, the safety training module. I mean, in an environment with molten metal, high pressures, heavy machinery, following safety protocols isn't just about ticking boxes, it's critical.
Yeah, life and death sometimes.
It really is. So this module covers the high-risk zones, hazards around machine guarding, safely using auxiliary gear like robots or sprayers, and of course the constant danger associated with handling molten metal.
The sources mention specific protocols here that are standard but essential. Things like electrical safety, communicating hazards clearly, and the big one, lockout tagout, LOTO. For anyone listening who isn't deep in plant operations, what exactly is LOTO and why is practicing it in VR so valuable?
LOTO lockout tagout. It's a mandatory safety procedure. Before anyone does maintenance or repair on a machine, LOTO ensures that machine is completely shut off, de-energized, and physically locked so it cannot be accidentally started while someone's working on it.
Prevents horrific accident.
Absolutely. Practicing LOTO and also using the right personal protective equipment, PPE. Doing that in VR builds the correct habits, that muscle memory. You can run through the whole multi-step LOTO sequence perfectly, 10 times in an hour in VR, if needed. That repetition instills a rigor, making it almost automatic so a technician never skips a step when the pressure's on for real. This virtual practice literally saves lives and avoids huge liability for the company.
That's a really compelling case for VR right there.
Mm.
Okay, finally, the fourth module, and you could argue maybe the most critical from a business perspective, defect troubleshooting. This is where process control really hits the bottom line, right? Product quality.
Exactly. This module is all about improving yield and quality. It teaches users not just to see a defect, but to figure out why it happened. The sources specifically call out two really common, really costly defects, porosity and shrinkage.
And just so everyone's clear, when we say porosity and shrinkage in casting, what are we talking about?
Sure. Porosity, like we touched on with degassing, is basically trapped gas or air bubbles inside the final metal part. Looks like tiny holes or voids. It dramatically weakens the component. Shrinkage is different. It happens as the metal cools and contracts. If it's not fed properly with liquid metal during solidification, you get depressions on the surface or internal voids.
Both sound like major problems for quality control.
Oh, they are. Both are usually tied directly back to getting machine settings wrong, issues with metal quality, or problems managing the die temperature.
And the key here is a practical application in VR, right? It's not just identifying that's porosity.
Not at all. The VR scenarios make you figure out what likely caused it. Was the injection speed wrong? Was the die too cold? And then, crucially, you practice adjusting the settings in the simulation to fix the problem. You're building that root cause analysis skill.
Which has to be one of the most valuable skills in the whole operation.
You could definitely argue that. You learn how to solve those problems that kill your yield, but without actually scrapping real parts or wasting hours of real production time trying things out. It's a complete loop process control, keeping the machine healthy, keeping people safe, and ensuring good quality output.
Okay, that covers the what. Now let's talk about the how. Implementation. Die casting is global. How does this program handle things like language? And how can managers actually track if this training is, working?
Good points. Accessibility first, the program's already available in English, Hindi, and Marathi, which covers some major industrial areas. But importantly, they offer customization into other languages. So a multinational company can roll this out consistently across different regions without language being a barrier.
That's smart. And what about tracking progress? You mentioned oversight.
Yeah, that's where the HR dashboard comes in. This is the management tool. It essentially turns the training from just a cost into something measurable. Managers can log in, see exactly how each employee is doing, track their scores, see how quickly they're picking up skills.
And spot gaps.
Exactly. Generate reports that show where the team is strong and maybe where more focused training is needed across the organization. It gives everyone from the execs worried about overall efficiency to the plant manager focused on compliance, real visibility into the workforce's skill level. And, naturally, the Pathshala team provides the technical backup to keep the system running smoothly.
So pulling it all together then, strategically what we're seeing with this HPDC virtual training program is a pretty fundamental shift. It's taking die casting training from something often slow, theoretical, maybe risky and expensive, and moving it to being fast, hands-on, simulated. Basically mastering the skills in a safe zone.
Right. It makes a complex process more accessible, much safer, and just inherently more efficient because you eliminate the cost and risk associated with learning failures.
It really supports that core mission you mentioned earlier, building expertise to drive quality, efficiency, and speed.
Precisely. By giving people this immersive practice, you're essentially giving them the experience they need to operate effectively under pressure, but without the real-world danger or cost.
And thinking about that, the training is designed, as you said, to build resilience against process variability and uncertainty. It teaches the safe operating window. So consider this. Mastering these skills in VR, doesn't that ultimately act like an insurance policy for the real-world operation? You're protecting that expensive machine, ensuring quality.
That's a great way to put it. It's an insurance policy against error, against downtime, against accidents, against bad parts.
It's learning how to optimize when things are tough, but without the real-world price tag if you get it wrong. Thanks for joining us on this deep dive exploring how digital tools are transforming even the most hands-on, high-stakes industrial fields. It really makes you think how quickly this kind of virtual, high-fidelity training might become the standard everywhere that risk and cost are major factors.